All right, we're going to continue our study of using L'Hopital's rule to evaluate indeterminate limits. For this example, I'd like to look at what happens when L'Hopital's rule needs to be applied multiple times, because that happens a lot. So by review, remember that L'Hopital's rule states that if we have a limit of a quotient that results in an indeterminate form of either 0 over 0 or infinity over infinity, we can take the limit of the derivative of the numerator and denominator to evaluate the limit. So let's take a look at another example. All right. So on this one here, if we plug in infinity to the x value, we'll get infinity on the top, infinity on the bottom. That's indeterminate. Let's apply L'Hopital's rule. So we're going to say the limit as x approaches infinity of the numerator that equals infinity. And we'll show that the limit of the denominator that equals, what does that equal? Well, that equals infinity minus infinity. So that's actually indeterminate itself. So let's do a little bit of algebra here. So I factored out an x squared, and now we'll evaluate, and I get infinity times 1 minus 0, some number going to 0. So we're going to just say that's infinity. All right, so we've shown that these are both infinity on top and bottom, so we could apply L'Hopital's rule. Of course, we would probably just factor an x squared out of the top and do it the old conventional way, but we're practicing L'Hopital's here. So we're going to conclude by L'Hopital's so we'll definitely document that. I'll just say L'Hop. By L'Hop, we know that this limit here over x squared minus 3x. We know that that limit must equal the limit of the derivative of the numerator over the derivative of the denominator. So we're going to say that. Let's see what that gets us. Well, that gets me 2x plus 4 on top. And on bottom, the derivative of x squared minus 3x is 2x minus 3. All right, so now we can plug in infinity for x, but again, we get infinity plus 4 and infinity minus 3. That is another indeterminate form. So we have to go through this whole process again. We have to say that the limit of the numerator is infinity, and it certainly is, so we'll just document that. And we need to say that the limit of the denominator is infinity as well. Then by L'Hopital's, we know that this limit here and we'll start by rewriting it, and then we'll show what it's equal to. That limit must be equal to, well, let's take the derivative of the numerator and the derivative of the denominator. The limit of the numerator here is, the derivative of the numerator is 2, and the derivative of the denominator is 2, and the limit of a constant is simply the constant, and 2 divided by 2 is 1, and we're done.